The maximum straight line retardation of a school bus under braking is 6 meters per second squared. What is the minimum stopping distance of the bus from a velocity of 72 km per hour to what does this distance become if the velocity is twice the original value? So we draw the velocity time graph, but our velocity will convert from kilometers per hour to meters per second. 72 kilometers per hour is equivalent to 72 times 1000 meters over 1 hour times 60 minutes times 60 seconds. So you have it to be, this time this is 36, 72 divided by 36, 20 meters per second. Here will be 20 meters per second. So we want to find the time it took the school bus to come to rest finally. So we can say acceleration or deceleration or retardation in this case is equal to velocity over time. That implies that the time is equal to velocity over deceleration. So we have it to be 20 meters per second divided by 6 meters per second squared. So it's equal to 20 meters per second times squared s squared over 6 beta. So m will cancel m, this will cancel 1. So you have 20 over 6 seconds. 20 over 6 seconds, which is approximately 3.33 seconds. 3.333 seconds. So here is about 20 over 6 seconds. Therefore, the distance traveled before stopping is equal to area of the triangle. It's half base times height. The base is time. The height is velocity. The distance now is s, if you like. Half times time to get here is 20 over 6 seconds. Velocity, the height is 20 meters per second. Second cancel second. Then this is 12. 400 over 12 meters, or approximately 33.33 meters. So the second one now will be, if the velocity is doubled, then v, it becomes 2 times 72 km per hour, or 2 times 20 meters per second, which is 40 meters per second. That means that the velocity will be somewhere here. The distance traveled before stopping will be s40, if you like. This one is s20 meters per second. S40 is equal to half times time times velocity. So but t is equal to velocity over a. So velocity is 40 meters per second and a is 6 times 1 over 6 seconds squared per meter. So we'll have it to be 40 over 6 seconds, or approximately 6.66 seconds. Therefore, this one now becomes the distance traveled before stopping is equal to half times 40 over 6 seconds times velocity. Velocity now is 40 meters per second. 0 over 12 meters, approximately 133.33 meters. So you see that the time doubles. If the velocity doubles, the time doubles, like this. So here is 40 over 6 seconds. We can solve it analytically if you like by using the formula v squared is equal to u squared plus 2as. S is the distance traveled. If we do that, final velocity is 0, so 0 is equal to, the initial velocity for the first one is 20 meters per second, so 20 squared plus 2 into, remember this is deceleration, not acceleration, so it will be minus 6 times s, and this implies that this is 12, take it over here, becomes 12 s is equal to 400. Therefore the distance traveled s, 20 if you like, is 400 over 12, just like this one, and it's approximately equal to 33.33 meters. Also, if we do it for the second one, you see that you have 0 is equal to 40, because we have doubled the velocity, 40 squared plus 2 into minus 6 s40. This one is s20. This implies that 12 s40 is equal to 1600. Therefore s40 is equal to 1600 over 12, and that's exactly what we got graphically, and it's approximately 133.33 meters. So that is how to do this type of problem. Kindly subscribe and like the video. Bye.